In this video, we're going to look at limit notation. This will come up in our study of functions in the next 3 to 4 chapters. So we want to make sure we have a good understanding of it. So we want to be able to read and write limit notation. We want to be able to find limits using graphs. We're going to talk about one-sided limits, and then we're going to be able to determine the general limit of a function using the left and right limits. All right, so just looking at the notation of limits, anytime you have a limit, you will see the word or the letters LIM, which stands for limit. Underneath the LIM, you're going to have X usually, or some variable, an arrow, which means approaches, and then either another variable or a number, which is going to represent the X value, which we are investigating. Afterwards, you'll have your function, and the answer to a limit is always the Y value that corresponds to the X value that we're investigating. When you see this notation, the way that you should read it is the limit as x approaches a of the function f of x is equal to L. There's 2 more notations that you need to be familiar with. These are the one-sided limits. That's called the right-hand limit and the left-hand limit. The plus side tells you that you're looking at the right side only of the function at that x value. If we want to look at the left side of the function for the given x value, then we're going to use the negative side. So this is telling us that we want to look at the left side. All right, so let's look at a couple examples here. This first one is the limit as x approaches -2 from the left side, because of the negative sign, of this function f of x, which is graphed over here to the right. The left. So this, remember, is my x value, so I want to find that x value. So here is that x value on my x-axis, -2. And then we want to look at the function from the left of that. So what you can think of is, once you find that x value, kind of give yourself a vertical line. Because of the negative sign, I want to look at the left side of that function. Just kind of pick a point just to the left of that function, and then think about traveling along that function towards the vertical line. What is the y value that you're approaching? So in this case, we're approaching the y value of 3. So my limit as x approaches -2 from the left is equal to +3. Similarly, this next one says, what's the limit as x approaches -2 from the plus side, which means the right side. So again, I'm at that same value, -2, and we have the same vertical line. So I'm going to come just to the right side of this function. So if we pick a point over here and then move towards the vertical line along the function, again, I'm looking at finding the y value that we're approaching, and we're approaching that same y value of +3. Since the right-hand and left-hand limits are equal to the same value, then we would say that the general limit, so the limit as x approaches -2 of f of x, is also 3. All right, so this next one says, what's the limit as x approaches 1 from the left side? So again, here I'm going to come to 1 on my x-axis. I'm going to come to 1 on my x-axis, and I'm going to draw a vertical line here. Since we're going on the left-hand side, I'm going to be on this part of this graph. So I'm going to pick a point over here to the left side. I'm going to move towards the vertical line. What is the y value I'm approaching? It's an open circle, and that's perfectly fine. It's still the y value that I'm approaching, and that y value is +1. When we do the right-hand limit, we're going to look at this part of the graph. So just to that vertical line at 1 is my graph that is sort of down there in the negative section. I'm going to pick a point here. I'm going to move towards that point, and that is approaching a point that has a y value of -1. In this case, my left and right-hand limits do not equal the same value. So in this case, we would say the limit as x approaches 1, f of x. So remember, this is my general limit because there's no direction given of the right-hand or left-hand side. So this is our general limit. So this limit does not exist. So when the right-hand limit and the left-hand limit are not the same, then we're going to say the limit does not exist. On the example at the top, the left and right were equal to each other. And when that is the case, where the left and the right side are equal to each other, then the general limit is equal to that same value that the left and right-hand limits were equal to. All right, let's look at a couple more examples here. with the same function. So this is the limit as x approaches positive 4 from the left-hand side. So here's my 4 on my x-axis. There's already a vertical line there because that is my asymptote. So since we are doing the left-hand limit, we're looking at this part of the graph. So if we pick a point over here and then we move along that function towards the vertical line, I'm going up forever. So if we're going up forever, we would say that this limit is infinity. Here we have the right-hand limit of that same value, so I'm here. Again, if we pick a point on here, and we start moving along the function as I get closer to that x value, which is the asymptote, then I'm going up forever, so infinity. So here the limit as x approaches positive 4. The general limit of f of x is either, we could say infinity, or we can say does not exist. Technically, a limit implies that you're approaching a value, although sometimes it's just good to put the infinity down because you know that it is on the left and the right side going to positive infinity, and it helps you figure out some more of the properties of that function. So either answer would be acceptable. This last example here is the limit as x approaches infinity. So when you have infinity in your x value, this means what happens as I go to the right forever. So in this case, what I'm looking at is if I continue this part of the graph forever, what's going to happen? So remember, anytime if you're given a graph, you can assume that you were given all important parts of that graph. So if this was going to intersect the x-axis, they would have given you that. So we'll assume here that it's just going to continue to get closer and closer to the x-axis, approaching it, but never crossing it. So as we go out here forever, if we think about a point on here, moving this way. So we're thinking about the y value. The y value is getting smaller, 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 and closer to 0. So my limit as x approaches infinity of f of x would be 0. Okay, so a few more examples here with a new function. So here we have this function 2x squared over 4 minus x squared, and we have the graph of the function. So we're looking at the limit as x approaches 2 from the negative side. So again, here I'm going to find my value of 2, which would be here. So again, I have an asymptote there. We're going from 2 from the negative side, so to the left. So to the left, it appears that I'm going up forever. So my limit would be positive infinity. Similarly, we're looking at 2 from the right-hand side. So here I'm going this way, I'm going down forever. So in this case, we are approaching negative infinity. So my general limit here, the limit as x approaches 2, infinity and negative infinity are definitely not the same thing. So again, here we would have to say this limit does not exist. The other 3 examples are similar, but we're approaching the value of negative 2. My negative 2 is over here again at the asymptote. So when we're looking at this from the left side, I am going to go to the left, and this one is going down forever. So negative infinity would be my answer. From the right-hand side, this is going up forever, so positive infinity would be my answer. And then again, the general limit, since those are not the same, is going to be does not exist. 2 more examples here with limits that are approaching infinity. So this is the limit as x approaches infinity. So remember, this means go right forever. So as I go out to the right forever, I am approaching this horizontal asymptote, so my y values are getting closer and closer to this asymptote value, which is at negative 2. So my limit as x approaches infinity is going to be negative 2. On the other side, as we go to negative infinity, so this is going to be going left forever, I'm approaching that same asymptote value, which is negative 2. So this limit also is negative 2.